When I first saw this problem, I didn't expect it to be tricky, but to my surprise, it took me a while to figure it out. So, we have a circle inside a semicircle, and two distances are given. Can you determine the radius length of the circle? Without any delay, let's crack this problem open. First, let's locate the center C of the semicircle. We don't know yet the exact location, so this is just an approximation. Next, let A be the point of tangency of the semicircular arc and the circle. From the center C of the semicircle, draw the line towards point A. Since A is the point of tangency, then segment AC must contain the center of the circle. Let's call that center point O. From center O of the circle, draw this radius and also this radius. Let R be the radius of the circle. Since this is R units long, then this distance is also R units. Next, let capital R be the radius of the semicircle. By segment subtraction, the length OC is equal to capital R minus R. Next, let this distance be D. Then I'm going to apply the Pythagorean theorem on the shaded right triangle. The theorem explains that the sum of the squares of the legs is equal to the square of the hypotenuse. Therefore, D squared plus R squared is equal to R minus R all squared. Transpose D squared to the right side, and the equation becomes R squared is equal to R minus R all squared minus D squared. This equation is crucial in this solution, so keep this equation in mind because we'll get back to this a little later. For now, let's proceed. Observe that the sum of the distances 7 plus R is equal to the sum of distances R plus D. I'm going to write it down. What we should do here is to isolate the value 7 on one side. So transpose R to the right side. The equation becomes 7 equals R minus R plus D. I'm going to put a parenthesis here. Next, notice that this distance is also the radius R of the circle. Therefore, by segment addition, the sum D plus R plus 2 is equal to the radius R of the semicircle. Isolate the value 2 on the left side by transposing D plus R into the right side. The equation becomes 2 is equal to R minus D. I'm going to put a parenthesis here. From now on, we'll be doing purely algebra, and we don't need the diagram anymore. The ultimate trick here is to multiply the equations. 7 times 2 is 14. And then, multiply the right side expressions like how we multiply binomials. Multiply all elements of one binomial to all the elements of the other. R minus R times itself is R minus R all squared. Next, multiply these terms, and that is negative D times R minus R. Next, multiply these, and that is D times R minus R. And lastly, multiply the last terms, and that is negative D squared. It may look complicated on the surface, but it is not. In fact, we can cancel out these scary-looking expressions because they are basically the same expression but with opposite signs. Now the equation becomes 14 is equal to R minus R all squared minus D squared. Does this exact expression look familiar to you? Yes, it was the expression we obtained from the previous step. This expression is equivalent to R squared, and this small r is the radius of the circle, which is what we need. Therefore, equation becomes R squared equals 14. Just take the root of both sides. The radius of the circle is square root of 14. The solution is so clever, isn't it? If you enjoyed this video, go ahead and subscribe to this channel so you can watch more geometry puzzles. Thanks for watching.